Okay, let's keep talking about these functions and function notation and what it means. So here's some reminders here on function notation. Specifically, remember this is naming our function. What's inside the parentheses is the x, and whatever it equals is the y. This stuff over here is the y. All of this together is also the y. Of course, they're both y because they're equivalent to each other. So those are all the different ways that you can think about it. So let's look at an example. First of all, remember, it does not mean multiplication. It means f of x. So when they say find f of 2, this represents our y value for an x value of 2. All right, so where's this function f? Well, output 3, input 2. Do we have the function? It's up here. Okay, 9 minus 4x. So really, we should have called that f of x. So if I plug in x of 2, I get this, which simplifies to 1. So what I'm saying here is when x is 2, y is 1. Or I could say x equals 2, y equals 1. That's what this notation right here means. I plugged in 1, I got it. I plugged in 2, I got an output of 1. Okay, so we can think of output, input and output as well. So let's go over some of the practice here. This means find the y value when x is 2, negative 2 for the given function f of x. So I recopy this given function. I plug in a negative 2. And I get negative 2 squared is 4. 4 times 2 is 8. 8 minus 1 is 7. Okay, so I could rewrite f of negative 2 equals 7 to rewrite my final answer. Remember, it means if the x is negative 2, the y is 7. I can write that a couple different ways to help you understand it. Another thing to think about, when we write this f of x equals 2x squared minus 1, it's just like it's a function with input and output, right? So let's think of it this way. X is the input, right? So x is just a placeholder, like we're going to put something else in its place. So you really should think of it like this. There's nothing inputted in there. And then they're going to tell us what to put in. So in this case, it was negative 2. So let's look at f of negative 5. If I recopy f of x and I take out the placeholder x and just leave it blank, right? Instead of having x as my placeholder, I'll just put a blank set of parentheses as my placeholder. And what do they want us to put in place of x? They want us to put in a negative 5, or that's our input into our function. So then f of negative 5 will equal 2 times 25 minus 1, 50 minus 1. So f of negative 5 equals 49. Okay, now this one's a little bit different. So if we rewrite our function with our placeholder, what was it? It was 2. There's 1. This is saying, what if our input is still x? So now I can put an x in there. And they say it equals 33. So if f of x is equal to 33, remember, f of x means the y value, which is over here. So I can take out that f of x and write in a 33. And now I want to solve that for x. So I'm going to add 1 to both sides. Then I'm going to divide by 2 on both sides. And then I can square root. And remember, you also get the negative version. So this is really saying when y, remember f of x means y, when y equals 33, then we know x can either be 4 or negative 4. Looking at the graph, what is the value of f of 2? So if we look over here on the graph, remember that the value of f of 2 means f of 2 is the y. So they're saying what is the value of y when x is 2? So I locate 2 on the graph, on the x-axis of the graph. I look up or down till I hit the graph. I hit the graph up here, and then I look over and see what is the y, because that's the question. The y is 7. So f of 2 equals 7. That means when x is equal to 2, y is equal to 7 on that graph. Remember, I could write it as the point 2, 7. what is the value when f of x equals 1? So now they're saying when y equals 1, what is x, right? X we don't know. So again, I go to the graph. This time I go to my y-axis because we know y is equal to 1. And then I look left and right and see when I hit the graph. I hit the graph in two spots. I hit it here at -1 and here at +1. So I look at what, again, I look at y equals 1 and I look across till I hit the graph at those 2 points. Then I look down and see what x values does that happen at. So x equals -1 and 1. All right, so now we're going to fill out this table using the functions given here, f and g. So solve for x if g of x equals a -18. Okay, so we want to say, in words, we would say like g of x is our y value. So we're going to substitute -18 for y, or g of x, because they're the same thing, right? And then solve for x. So if we plug in -18 into g, we pull this function down here, we put in a -18 for g of x, and then we solve this thing for x. Okay, so because they want to know what's the x. So I'm going to add 15 to both sides. -2x equals -3. Then I divide both sides by -2. And I get -3 divided by -2, which is 3 over 2. So my final answer is x equals 3/2. F of -2 plus g of 4. This is now telling me an x value, right? And then I get a y value when I plug in that x value. Same thing here, I get a y value, and then I'm going to add those together. So I'm going to substitute -2 in for x in function f. Then I'm going to, that's step 1. Step 2, substitute 4 in for x in function g. That will produce that'll produce 2 y values. Now then it says to add them right here. So then I will add the 2 results, or the 2 outputs, or the 2 y values. All right, so f of -2 plus g of 4. So f of -2, when I plug -2 in for x, I got 3 times -2. I could, we'll just do it out. 3 times -2 is -6. -6 plus 10 is 4. So this whole thing becomes 4. G of 4, when I plug 4 in for x here, 4 times -2 is -8. -8 minus 15 is -23. Now I can add 4 plus a -23 and get -19. Okay, so our final answer is -19. How do we deal with this when we have 3 times the function f of 2? We're going to ignore this one. I don't like this one. Actually, we won't ignore it. I'm going to rewrite it differently. This is how we would rewrite it. Okay, so what are we going to do here? We're going to find the value of f of -2. And now I'm saying that differently. Up above, I told you how to find the value. I said substitute in for x, right? I'm hoping you know now that when you substitute in -2, this means substitute in -2 for x, you get a y value, which we already did right here, right? So we know that that's going to be 4. So we're going to find the value of that and then multiply by 3. Because this means 3 times the value of f of -2. So I'm going to have 3 times 4, right? Let me write this out. 3 times f of negative 2 is really equal to 3 times 4, which is 12. How do I know f of negative 2 is 4? Because we already figured that out up here in this problem. We got that by plugging negative 2 in for x. We're going to rewrite this one. F of negative 2 divided by 6. So it's the same idea. We're going to find the value of f of negative 2 and then divide by 6. So f of negative 2 divided by 6, that's equal to 4 divided by 6, which is 2/3. How do I know the value of f of negative 2 is 4? We found it up here. We've already done it by plugging in negative 2 into the function f of x and then simplifying. Okay, this one is a function inside of a function. It's like a nested function. So we always start from the inside out. So we're going to say start from the inside most function, or parentheses, or however you want to look at it. So step 1 is to evaluate g of 4. Okay? And when you have a function inside of a function, that's called the composition of functions. So that means we input 4 into g, and we get an output of, let's see, if we put 4 into g, we already did that up here, right? So we found out g of 4 was negative 23. So we get an output of negative 23. So now we could rewrite this as f of negative 23. If we look here on the over here in the notation, I didn't do anything with f. What I did was I found g of 4 equals negative 23. So now I can substitute in negative 23 for g of 4. And now I work with the outermost function. So step 2 is evaluate. I don't know why this is skipping so much. Let's see if we could fix that. Okay, I did a restart, and let's see if it fixed it. So I was saying that now we're going to evaluate f of negative 23. So what's interesting to note here, evaluate f of negative 23. The input for this next function is now negative 23, and let's see what our output is. In composition of function, that's what happens. The output of the inner function becomes the input for the outer function. Whatever you get out of the first function now becomes the input into the other function. So f of negative 23, we have to now go plug that in to f, and let's see what happens. So if I plug in a negative 23, that means I'm doing f of negative 23 equals 3 times negative 23 plus 10. So 3 times negative 23, what is that? That's going to be, let me get out the calculator. Negative 69, then I add 10 to it, so I get negative 59. All right, so over here we're showing the steps. I guess I did all the steps over here, but let's show that. F of g of 4. So that means first I find g of 4, which we knew was equal to negative 23. Then we now have to take that g of 4 and rewrite it, plug in, get rid of the g of 4 here, and I can substitute in a negative 23. So now I can find f of negative 23. That means the input for the function f is negative 23, and the output that I get is negative 59. So the final answer is negative 59. Here's another composition one, g of f of negative 2. I want you to pause the video here and see if you can do it without me. Okay, welcome back. You should get an answer of negative 23 on this one. So we can talk about that in class if not, if you didn't get that. All right, let's look at this last one here. What happens when it's not a number to input? So that means that f of x is really like you're taking out the x and replacing it with x. So I already know that f of x, right, what it's equal to. You could think of input and output if you like. X is a placeholder, right? So if I take out the placeholder and leave it blank, and then I replace it with x, that's going to be my input. I'm going to get the same exact thing back. So you could look at it as we already know the function f of x is equal to 3x plus 10. So another interesting thing to note, when your input is a number, notice your output is a number, like here and here. When your input is a letter or a variable, your output will not be a number. It will have a variable or a letter in it. It will be an expression. So this means put the entire function, or I'll just say put the function f of x in for x. And we're going to use function g for that. How do I know that? Because g is the outer function. F is the inner function. So I'm going to plug x into f, and I'm going to get f of x as my output, or my result. Now I'm going to take that result and plug it into g. Let's take a look. G of f of x means, first of all, f of x equals, I start inside, f of x equals 3x plus 10. Now g of f of x means g of, I'm going to take out the f of x, and I'm going to replace it with what it's equal to. 3x plus 10. So that's going to be equal to g of x. Actually, before I put in what it's equal to, let's just leave it blank. Let's do the placeholder thing. So for g of x, I'm going to take out my x and just show it as a placeholder. And no matter what I want to plug in here, it could be a number, or it could be an expression, or it could be an equation. Really, we just want to talk about expressions. What I'm plugging in here, right, that was our placeholder, negative 2, placeholder minus 15. So g of anything equals negative 2 times that anything minus 15. So I'm going to plug what f of x is equal to inside. Right, because f of x was inside. So now I'm going to take that f of x out and put in what f of x is equal to. So essentially what's happening here is if g of x is negative 2x, I'm trying to explain it a couple different ways, and f of x is 3x plus 10, you're taking the whole function f and plugging it in here for x. That's how I get this. It should look familiar. You do this already when you simplify, or when you solve a system by substitution. You go 2x plus 3 plus times 2x plus 3 equals 12. Right? So those are probably bad numbers because they're a little confusing. But we take this guy and we substitute it in for y. Right? That whole expression gets plugged in for y. That's what we just did here. This whole expression gets plugged in for x. And now I can simplify this. I distribute the negative 2. You can say over here that g of f of x equals negative 6x minus 35. Again, the summary here is that function notation has an input and an output, and you have to know how to read these kind of statements. This is plugging in negative 2 for x, and what you get out is equal to f of negative 2. The output will be equal to this entire thing, or the y value.